exactly the Avl tree and how to go for the insertion of few elements in the Avl tree. So Avl tree is nothing but the Adelson, Volsky and Landis tree. One set of BST. Only the thing is here we are going for the balance factor, that is with certain values like -1, +1, 0. So everywhere it has to be satisfied. Only we can say it is Avl tree with the balanced nature. So these are the elements which we want to insert. The very first element is inserted, that is 55. This is what 55. When only 55 is inserted, there is no left or right subtree. That's why its balance factor will become 0. That is 1 minus 1. So it will satisfy the AVL condition. So it can be perfectly inserted. Next is 25. 55, so it has to be at the left hand side of the 55. So we calculate the balance factor for the 25. So at the left nothing, there is no child, so its balance factor will become 0. Similarly for the 55, left we can say it is the only one node that is attached, or you can say that it is nothing but only one path is attached to the node on the left side. So here we can say that we do have the balance factor for this one is left subtree minus right subtree, so it will become 1 minus 0. So this is what the value 1. Similarly, when we go for inserting the next element, let's say it is 65. So since 65 is greater than 55, so it has to be to the right of 55. So we just inserted it, and after insertion we need to calculate the balance factor of each and every node. If it is disturbed, means if it is not satisfying this particular criteria, then we need to go for the balancing of the tree. Okay, right now let's say it is the 65 which has been inserted. So we can just check here, balance factor of 25 is 0, balance factor of 55 is 1 minus 1, so it will become 0, and balance factor of 65 is also 0. So that's why 65 is perfectly inserted over here. Now let's check when we insert the next element, that is 9. Since 9 is firstly compared with 55, it is less than 55, so it has to be at the left of 55. It will be compared with 25, it is less than 25, so it has to be at the top 25. So after inserting 9, this is what the scenario. So let's calculate the balance factor 0, because 1 minus 1 is 0 for 9. Then for 25 it is 1 minus 0, so it will become 1. For 55 it is 2 links, that is this is first one, this one is second. So 2 minus this, so it will become 2 minus 1. So balance factor 1. Similarly for 65, it is 1 minus 1, actually it is 0. So for the 65 we can see that it is also 0. So overall we can say that this is after inserting 9, it is satisfying again the same condition of balance factors, that is minus 1 plus 1 plus 0. Now the next thing is, let's insert the 8. Now when we insert the 8, we can just check here, 55, then 25, 9 and 8. So 8 is achieved the location which is left to the 9. So if 8 is inserted, it got disturbed the balance factor of nodes. So let's analyze it from the root. So at the root, we can just check it. This is first link for the first edge, second edge and third edge till the leaf node. Okay, so 3 minus 1, so this is what the balance factor for 55, this is the balance factor for 25, that is 2 minus 0, this is for 9, and this is for the, and for the 65 again the balance factor will be 0, because there is no left or right child. This if we just check it, it is not satisfying this particular condition over here. So since this condition is not satisfied after insertion of 8, we need to balance this tree. So since 8 is providing the disturbance to the overall arrangement, that's why we need to go over here one operation that is called as a LL rotation. So LL rotation will do this kind of stuff. Is when we go for rotation, it will be like this. So this is nothing but the left rotation, because At the left side, we just got the disturbance in the arrangement and the balance factor is got disturbed. So after this, it is quite simple to understand that whatever the elements here we are observing, that is 8, 9, 25, one can arrange them in a ascending order, and this is what left rotation will become. So once it is left rotation, 9, which is nothing but the second element for these three elements 8, 9 and 25. So it will become the root, and right will be the 25 and left to the 9 will be 8. So this arrangement, let's check what exactly the balance factor for 55. When I calculate it for the left subtree, it is one edge and two edges are there to reach to the leaf node. So it means it is 2 minus, at the right it is 1. So 2 minus 1. Now 55 will have the balance factor 1. 9 will have 1 minus 1, that is 0, so which is provided here. 8 will be 0, and for the 25 also 0. For 65 again it will become 0. So this is how after inserting 8 we can have the balance factor arrangement like this, and after rearranging the elements it will do like this. Now the next element which can be inserted is nothing but 15. So if you insert 15, it will be obviously less than 55, greater than 9 and less than 25. So it will achieve this particular location. But after achieving this location, we can just check here that not disturb the overall arrangement. So here one can just check, yes, the arrangement of the balance factor is disturbed. So for 55 the balance factor will become 2. For 9 it is 1 minus 2, that is minus 1, and for 25 it is plus 1. So these are the two where the balance factor is disturbed. So in order to check which particular rotation is being applied over here, we can just check. We do have the left and then right operation. So that's why the LR operation will be performed over here. Now how to perform the LR? So when we do have the LR first, then first of all let's perform the LL operation. So this LL operation, uh, this LR operation, one can just check that this arrangement for elements like 9, 15, 25 and 50, it is been disturbed over here. So this 25, since it is greater than 9, so obviously it will be to the root of 9. So this is what the LL. So firstly we can go for the LL operation over here. So 25 will be at this location to the right of 9. We do have the element that is 15. So this is the first operation which we can perform over here. After this, obviously we can just go for the operation that is nothing but the right. Since right we can rotate, so this right rotation will be in this particular operation like this. Okay, so when we just rotate over here, so 25 will become root, and to the right of 25 we will have the 55, and to the right of 55 we will have the 65. Just we can observe in the earlier stage. So this is how the LR rotation in short will be completed with the LL and then the right rotation. So this is the final answer after inserting the element, that is 15. Okay, so it got disturbed the overall arrangement. This is the final answer which we can guess out. So this you can just try out for multiple examples based on the Avl tree. Before proceeding to this, let's go for L, single left, single right, RL rotation, LR rotation, like this. The rotation has to be studied. So thank you very much.